Oh, we gotta figure those tables out.
Oh my God. Oh, that's such a trade.
That's not gonna work.
Yeah. I thought it was low-key better before.
Yeah.
Like it
was,
I could get like turn around, but
like it was kind of fine, like there was plenty of space in the room.
it was not better after we moved.
I mean, we also arguably not figure out how to do it. It was so funny.
Had we actually spent like 10 minutes trying to figure it out, it would be good.
Yeah, I think every road moved in real quick. Yeah, he's like, we can't just like move the tables back real quick, and nobody's ever been in that room, and so they don't know what it's supposed to look.
Yeah.
Except for like a couple people that might have been to any of the max year dissertation presentations.
I'm like, I
That's
don't
it.
know what this is supposed to be. I'm sure it'll be moved. And so, you know, it's on that, all of your son that too. Yeah, oh, yeah, he just parked. Well, he's gonna be late. I'm here at Berlin. He'll be late, but oh my God. Oh, he's not super far though.
Yeah.
You know, he'll be
Maybe like 5 minutes.
He'll be much better. He'll be fine. There should be, I just like the longest possible way to get.
Yeah, I got to 103 and thought that the hallway stopped, but then I realized that there was like.
Way that goes down to.
Yeah, I almost went down.
I went down there last year, just felt like you're not allowed down there.
Yeah, not.
Oh, down there is agricultural printing. So it doesn't mean that it is only for agricultural people. We can use it as well, like posters or booklets. I didn't take with me things, but the this technology is a little smarter than myself. Oh,
There we go.
do not touch it. Right. So yeah, everyone is welcome to come, but we close the door. So I was playing a game, but it's very small audience. We can play open cards. So first I was scaring everyone with like hard homeworks, and then telling, do you guys want an exam or a project? And then everyone, yeah, we want a project. And then project is easier for, well, it's not about same work as for exam, but it is less stressful for participants and more fun for me, because I hate grading and being responsible for like lowering something. It's better just. But it's in the past it was arranged as a like sometimes in the middle of semester voting, so that everyone votes for project. Sure, I'm happy to. But to practice a little bit of physical chemistry, we'll do homeworks anyway, so that my colleagues do not criticize me, so that we skip important parts of the education. About printing, so if later on everyone will vote for projects or majority, right? The replacement of an exam is a little research which is formulated as presentations and term paper, and then we combine it in a little book. And hey,
As always.
you are in wet chemistry.
TCAL?
No,
Oh, organic.
organic. And you were starring on the photographs for the
Yes.
web.
Yes.
I already forgotten your name.
Sam,
Sam, Dmitry.
pleasure to meet you.
Pleasure to meet you again. We were, yeah, probably I should show these photos. We were just browsing the webs and making everyone photos, just pouring liquids or,
Me doing TLC plates. Yeah.
and then a professional photographer and journalist like took maybe 1 out of 400.
Huh.
So
Oh, you're the chosen one.
Yeah. So when do I get my like reimbursement from the university? Royalty?
Royalty. Yeah,
royalty.
sure.
Royalties?
Oh, and you guys are all okay with if the camera starts working to be recorded, photographed, so no one objects this publicity.
Very photogenic.
Just provide you with royalties and everything will be okay.
I'll go to Dr. Cook, the president, not chemistry department.
Big cook.
Yeah, big cook, the big cooks.
So do you like exams, Sam?
If you give me an A on them.
Like
Sorry, if I earn an A on them.
yeah, sure. There is a plan to first scare everyone with very hard homeworks that undoable, and then tell, do you want an exam? And or an easy project, and everyone, yes, let's do a project.
I'd rather do a project.
Yeah, we'll do a formal voting, but it's probably predictable.
Is this the entire class? Is anyone
Joe
online?
should be.
With Joe.
Joe,
I thought you
You?
were.
Yes. So he's doing
oh, like Joe.
Yeah.
Oh, word. Okay.
are you guys like chemistry to physics friendship?
I tutor with him.
Huh?
I tutor with him.
We all know each other.
Like you tutor him or he tutors you?
Oh, we work together. He's a physics tutor.
Oh.
Like Joe was the in your research.
Right,
group.
right.
Yeah. He's a supervisor at ACE. So I
Okay,
work under
okay.
him.
Okay.
Is he like? This class or is he like in the class?
He's not registered for the class because he's already like overloaded, but I recommended him to at least join the lab. And I'll talk about the lab because the word lab is a little scary because you came to do like books, pen and paper, which lab? But for his research, if he gets flavor of what we are doing here would be useful. So I'll include him in the emails and share class materials. What else? So and by the end of semester, if voting will be as predicted, we'll do little write-ups and publish them downstairs at this agricultural printing because they do discount. They have designer on board who just improves whatever we do, and then you get booklets as a little memories from. I wasn't preparing, but typically I bring these booklets like to the first or second class from previous years, so they
I
can.
think I have the one that you gave me.
Oh, I did.
I don't.
Okay,
I don't
but
know where I went.
That's the one that you chose.
Yeah. I had to clear out, I went on a month-long trip, so I had to clear out my backpack of all unnecessary papers and stuff. And I guess unfortunately that was one.
okay. So what else you want to hear this first time? Maybe if I stand up, blood will circulate better. Something smarter. This syllabus is created only to please administration. I hate syllabus. Maybe you can look through and see, but I don't expect much. Oh, okay, so it should be different year. We may have. Oh yeah, I've got a new office.
Were you in South Engineering?
Yes.
Were you not on ladder Dunbar?
I noticed that you know that meaning of a sentence depends on the context, right?
Yes.
Like, so I was privileged to be part of the physics.
Oh,
No, when I joined the department, there were no good officers left at Lead and Dunbar, and there was a
exiled South Engineering.
right, and I think it is still. It's not listed as my office. It's listed like Club of Physics to Chemistry Friendship. So come there. I have a kid. right, yeah, friends.
Relations.
I mean, at least one of those professors has a dog.
Yeah.
Yes, Sky, right?
So.
It's the bigger dog is Sky, and the smaller one I don't remember. What else? New office, new year. Oh yes, and they kicked me out of this nice room, but maybe this one is not as bad.
Going QBB to the lab, right?
Yes, Moril, I don't know, Moril
101. That's little.
what do you study? Moril 101. Yeah, maybe the concept of the labs would be like curious. So in fact, we spend together in the classes about 5 hours per week, and it's if everything to be very formal, I probably need to apply petitions to make this class 5 credits or do an additional class for PChem. Well, there will be true PChem labs, like experimental, when you do like heat bump and spectra, and there it is to be clear, like in order not to induce wrong questions, let's call it like office hours or problem solving. But in fact, it is the word, so formally it's more like office hours, but in fact, what will happen at this time at that place will be very much like labs. So, and those young colleagues who completed this course like this office hours / labs much better than the lectures, because lectures, okay, they're recorded. I mumble the same thing every year, maybe with little variations. And in the labs, it is where we will accumulate skills that will make us able to complete the projects. And even if in the unlikely event that you vote against the projects, there are some benefits. So the problems in physical chemistry are very mathematical. And there are very few people on the globe who like mathematical problems because of the fact that one needs to invest a lot of effort, and the answer is not correct. Answer is not guaranteed, right? So, like, one can love physical chemistry but hate math, and to match this, to bridge this conflict, one can use computerized tools, where you just, as a big boss and director, formulate a problem, select the right code, and then it solves the problem for you. And strategically, you know as much as if you would solve it for like several hours by pen and paper, but practically it's same as an experiment. You just push the button and get the answer. Well, maybe I'm exaggerating the simplicity. There are little bells and whistles, but it is in this direction to simplify our lives. And we will have the flavor of both, like pen and paper solution, just to get a little bit of this example and to prove to outer world that we completed like classical parts of chemistry education with all things. But you'll see that through computational tools, one can be much more productive and solve same problems at no time. Okay. So what else? Just if if anyone wants to lead this discussion, please go ahead.
Everyone gets to know it.
Do not tell it outside of the class. Well, there were events when a student in a class, well, was not yelling at me, but was skipping like half of the classes and not doing assignments, and then he got B. Well, I haven't told it. You need to fear and be on your toes and do all assignments, but you are majors, you are future colleagues, so we shouldn't spoil lives of each other. So it in the plan of the class, there is a component of a little fear of the grade, but it shouldn't be too much. You just, if you're a perfectionist, you may get stressed, like, oh, I have invested 2 hours and didn't get the answer. I should give up math and do computational. So there will be this component, but more for like illustrational purpose. What else?
How was your summer?
Okay, good. Oh, thank you for leading the discussion. Really great. Thank you. How was yours?
It was hectic. Lots of travel, but had a lot of fun in the lab. You know, it was your star model of the chemistry website.
Okay. So did you synthesize anything?
I was helping Whiteout with just kind of like confirm and deny some of her like assumptions on reactions and different throughout the entire summer. So yeah, I was synthesizing kind of like the same type of reaction, which I had like different synthesis. Yeah, whatever. So yeah, it was fun. It was a really good experience.
What is activation energy?
Oh God, Berghaus is gonna kill me.
Workhouse? Why?
I was in his lab for 6 months, and we talked a lot about PChem throughout that time.
No, then we should switch places. You teach the course. I'll just provide slides or.
Energy is the energy needed for a reaction to like initiate or take place.
So basically, some transformation doesn't go. You put it on a steering pad, heating it up, and then it happens. Changes color or starts smoking or whatever, right?
I'm gonna say no.
Oh yeah.
That doesn't sound. That's not.
Teach us.
I don't.
Go ahead.
This is strictly off of just. I'm gonna say like assumption, but I don't think that's probably the right word. But activation energy isn't necessary. Like heating can help, but I don't want to say it's required because you don't necessarily need to heat all reactions. And activation energy, I believe, would be the interaction between two reagents that's needed for a reaction to take place. And I don't know if that's right, but that's kind of just.
So you are not as like discrete, deterministic, like under a certain temperature it doesn't go, above certain temperature it goes. You're telling that below activation, if temperature is below activation energy, it goes slower, above it goes quicker.
No. God.
I'm
failing because I have.
Hard to talk to experimentalists.
Help me out here, guys. I'm trying. At least I'm trying.
So eager to share your
Oh.
knowledge with us.
I don't want. Hey, yo, he put me on the spot. I'm just doing my best. I'm not going to sit here and say like I don't know. I want to at least make an attempt. Because no, and like, if you don't reach the activation energy, a reaction won't take place. It will not occur, I guess.
Mhm.
It's- Hit it, it will.
Mhm.
But once you reach your activation energy, you start to lose energy, but the amount you lose depends on if it's exo or endothermic. Because if you lose more than what you started at, hey, not long ago. Because if you lose more than what you started at, that's an exothermic reaction. But if you like, or I guess I shouldn't say lose or gain, wherever your your energy ends up, whether if it's below where your starting was, it's exo, if it's above, it's endo. And I feel like this is very, like, putting it in very layman's terms, but do you want, I know you understand what I'm getting at, but if I was explaining this to someone who didn't know what chemistry was or activation energy, do you think that would be a viable, like, explanation? Yes. But
So-
yeah, like where your product ends up depends on if it's exo or endo, where your enthalpy, your change in enthalpy.
Okay, okay. Yeah, I think we should swap places. You will just teach and I'll sit and learn from you
Okay,
guys.
so you pass, you pass, you pass, you pass, you pass. Everyone gets an A, have fun, we're not gonna do it.
Great. No, it's all great. Go ahead.
What would you say is probably like the most important thing to take away from physical chemistry or like
How to do physical chemistry.
No, there. So we started our acquaintance with my knowledge that Sam does see that meaning of a word or sentence depends on the context. So your question, the answer also depends on the context. So benefit or take home for you as future researcher, for you as just someone who needs grade to go to a different career, for you as a on academic path to go to the next class, or for me as a person who wants to hire as many students to do research with me. So the answer is different from each of these contexts. So if you already if you completed inorganic, then you don't want anything towards inorganic, but probably you still have mandatory PChem2, right?
Yes.
Okay, so what is taught in the PChem2?
I have no, oh, okay, actually, I do remember.
You do.
I remember the specifics. I believe this is more of like the quantum, I believe. This is like quantum chemistry is what we'll learn. Next semester is like the actual physical. You have the and you learn more, I think, about the enthalpy.
Which you already know, right?
Oh yeah, absolute master on it. You don't deal in the relative or the theoretical, you deal with the if this is occurring in a reaction, you look at more of the interaction of molecules rather than kind of things that aren't actually physically occurring. We deal more with numbers in this class and in terms of and less on physical states, I believe. I feel like I'm rambling and just digging myself a hole. This is quantum and theoretical, and next semester is more dealing with the actual interaction of the action. I guess probably. And that's what I remember reading before.
So let's practice our imagination and together with maybe some education. So by looking on this figure that looks like a bird, eagle with two wings. Have you seen this image in any of your research life?
No. We're disappointed. We're off to a great start here.
So the reason, well, chemistry is like synthesis and characterization, right? And characterization is basically a spectroscopy. You probe stuff with electromagnetic radiation of different things and see how it responds. So if one does far infrared spectroscopy of diatomic molecules, they are rotating and vibrating at the same time. And then if one looks for the response of diatomic molecule in this far infrared raw vibrational spectra, it looks this way. So it's like frequency, and this will be intensity. And the lines here are transitions between quantum states where this diatomic molecule rotates with different angular velocities. And they are quantized, discretized, therefore it has peaks. But the quantum part of physical chemistry will predict only positions of these peaks. But this pattern of some of them being more or less intense goes beyond the scope of this PCAM1, because this distribution of intensities will deal with the fact that some of the states are populated more, some are less, because of like Boltzmann distribution. Because those are that here are more populated, that are less higher energy, less populated, lower energy, more populated, right? So everything related to this, like statistical mechanics, statistical thermodynamics, occupations, thermal interactions with heat bath, enthalpies, will be part 2. And if one is interested to practice Boltzmann distribution for something, right, then you will put like exponential and then energy of your quantum state and temperature that system observes, right? So the question is where to take these energies. And if you're looking about PCAM2, then your take-home message from PCAM1 is we'll get practice on how to get these energies. So it's minimalistic, it's very narrow view, but in some sense, it's like energies that would be fed into Boltzmann distribution. It's not all, it's maybe 5% of the class, but it makes a connection. And I wanted to make a comment 10 minutes ago, but now it's too late. Arrhenius.
Yeah, okay.
So it's what we were discussing, right? You are friends with Arrhenius, right?
Fortunately, I've never made his opinions.
But you've heard about him, right? Yes, no. Long live Arrhenius, hate Arrhenius. Yeah.
I'm gonna be completely honest. I don't even think we covered it in 151.
I definitely recognize the name though.
I've heard it.
So it's Arrhenius is very similar to Boltzmann. I'm not sure if I can tell it in presence of like colleagues, but but with closed doors. So here is like population of a quantum level, right? Yes, but it's my cheat sheet. And here, yeah, the rate of a reaction is also some coefficient, and then e to the power delta E over kT. So the if the activation energy is small, then reaction is easily activated by heat. If it is large, it doesn't go, right? And I'm still under the question of what is the take home from the class. So Arrhenius barrier activation energy. So if I make an abstract image of an average student in this class, is someone who does synthesis, right? With activation, going from reactions to products. And one can just use Arrhenius and be happy, or one can draw this activation energy diagrams and just analyze the reaction and computing the energy of reactant, product, and activation, right? What is on the x-axis of this little diagram? I like time, but if someone disagrees, what are the options like time and what else?
Reaction progress.
Reaction progress. Are there any similar words like reaction progress, or if we want to be if you want other? You're absolutely correct. But if you want to be mathematical and other people to respect and fear you as very abstract mathematical brains, so just say the same thing in more upscale way. So degree of progress of reaction.
We're chemists, we're not mathematicians.
You're right, but
Critical thinking time. Let's put our 5 brain cells together. 6 brain cells, 7 actually. 2.
I should do a little puppet and pretend like here is one more brain.
What? Yeah.
What's the more abstract mathematical term?
You were the one that was going for a math and double major chemistry. Come on, Ava. Do you want some?
Like
Yeah, shut up, Sam. Because I just keep looking.
Oh, reaction completion.
like what are
Are you thinking of a specific term?
yes.
What letter does it start with?
Oh, Wheel of Fortune by Wawa.
Can I get a B?
No. When you study math, what are the concepts? Like there are the algebra and geometry, right? And calculus is next. But if you go with geometry, if you start drawing figures, if you like set an origin, just keep your axis, and if you move along the axis, you change axis vector.
Ray. Oh my God! I'm like.
Let's do it.
Ray.
Let's do it once again. So, origin, axis, another axis, vector, and if I just move along one axis and say here is my x, and here is my y, what are those x and y? Yes. So reaction progress or reaction coordinate.
We would not have gotten that.
Yes. So reaction coordinate, right? And reaction coordinate is something that will, like the word coordinate, a little bit throws you off as chemists and isn't for mathematicians, but the concept of reaction coordinate throws off both mathematicians and physics people, because it's like a reaction coordinate. It throws the mind off because it is not defined rigorously. So when reaction progresses, it like changes energies, it changes interatomic distance, several interatomic distances at once. It changes degree of charge transfer, it changes orbital. So everything is changed. It's an attempt to project the whole world of this group of molecules onto one line. It's like too much. But we can associate progress of reaction and abstract concept of reaction coordinate maybe with one leading process or one leading thing that is being changed. Like if you just take H2 molecule and dissociate it on 2 atoms, then the reaction coordinate probably will be just distance between these 2 atoms. In all other cases, it will be something different. Okay, You take it. Now, why? Huh? Oh, thank you. So, why do people need quantum theory, and what does it like in a lay language? How does it relate to chemistry? Just which associations do you get by hearing about quantum theory? Like who needs quantum? We have a no. We have nice image of pictures. We have potential energies along reaction coordinates. We have Arrhenius. Well, we need some energies here, but it's
Whenever I think of quantum,
Mhm.
when it comes to like chemistry, I think about like how you can know like an electron can go away in a particle. So like, and like you can either know it's the position or the speed, but not both. That is always what I associate with like quantum chemistry. Because that's like one of the few things that I remember always being told is like, it's like quantum chemistry, you never know one is the other, they're both. And I don't know.
everyone agrees. So now let's. No, you disagree. So the another narrow goal of physical chemistry is to serve as a translator. Like this discipline serves as a translator between verbal concepts that I use to analyze outcomes of experiments and math, right? One way or opposite way. And one of the sub goals of my task is to take words of Sam and translate them into math.
I think that's something that is desperately needed.
But what he summarized in like 30 seconds will keep us busy for a month on a mathematical language. So position and momentum or velocity cannot be evaluated and cannot be determined at the same time. An electron is like particle and a wave at the same time. What else? Which other concepts, visual concepts? Like some people are abstract, some people are verbal, some are mathematical, and some are visual. So which visual impressions come to your memories when you think about quantum?
But like electricity, I guess that's probably not.
when you put two fingers into power plug.
I was gonna say, I remember in high school, my chemistry teacher had like a bunch of like vacuums with, I think it was like gaseous states or something, and he like put it into like, some, electrical socket, and when electricity ran through it, each different element would go with a color.
We should do it. I do have this tool with me. Not right here, but we should do it before December. And
Yes,
yep.
I will. I'm just gonna slap a sticker right here. Don't forget the electrical stuff. Make the elements go.
So as
Inorganic. Yeah, how big is this guitar? We should just bring a bunch of rooms in the studio, and just have them like on the wall. There it is. Okay, that's what I was gonna say. We'll bring in the North High School kids. We want a day to just. Perfect.
Anyways.
yeah,
back to PCAM.
back to PCAM. So what is here?
The period, oh, that is a nucleus. No, yes.
Like if you like H, right? 1s, you know this Aufbau principle. Then 2s, you see it's like little raisin in inside of a. No, what is this?
2p.
How this two? Oh, okay, yeah, I'm very happy. And now we go to a little higher, and yeah.
I remember learning this in 150 with Rogers, and I was like, I have no clue what I am looking at.
So tell me more what they are.
The region where,
That's
most likely.
I'm gonna put it into PChem terms. 99% of the electrons will be found there. 1% could be anywhere else in the universe.
Okay. Probability. Okay. And when you told the word density in language, I was recently like traveling, switched on the TV in the hotel room, and they were showing Back to the Future when a character, like main character, wants to make his father to meet his mom, and he's very scared and doesn't know how to establish contact, and instead of telling the written words, "You are my destiny," he told, "You are my density." So density, or better, probability, right? Probability, it is inside. So electron is not in a point, it is in some area with some probability. Do we apply quantum theory only to electrons?
No.
Do we apply quantum theory to people?
Yes.
But not very efficiently. But which other objects can be quantized? We notice that, like, yes, for sure. So we have this diatomic molecule, right, which is rotating, and we can quantize rotational motion. Can we quantize oscillations?
I don't know. Why am I the only one?
Sure. I don't know, I'm just guessing.
Who is Raman, and why he got the Nobel Prize? No, not Bohr, huh? Who cares about Bohr? Raman. Let's look.
Oh, Raman.
You do, Raman. So what is Raman? Who is Raman?
All I know is that he has a spectroscopy in that.
Yes, but
Stop looking up the answers.
that's okay. That's okay.
Promise.
Well,
It's
you may
a
make
big
a-
one. I think yes.
it's a noodle bowl that.
No. It's the wrong letter. It's like if
Oh. I don't know.
just tell what's like, what is the difference between FTIR and Raman?
We don't know.
Come on, you know.
No say. I never learned it. We haven't learned it yet.
Me too. It wasn't a part of any class I took, but it is needed for life.
Is it now?
Yes.
Raman and what'd you say?
FTIR, Fourier transform infrared.
Well, I know IR, you are able to identify like functional groups and stuff on all.
Because each pair of atoms oscillate with its own frequency.
Yeah, so a set wavelength. Raman being, I remember I've seen it like twice. Burkhouse introduced it to me at some high level PChem class over the summer, my freshman year, that I had no clue the reason why I was in. I don't know.
So
I'm gonna pull up.
yes, yeah, pull out. So and I'll start speaking, but maybe you'll find it better than I will be able to formulate. So when one is exploring just standard infrared spectra, one is probing and detecting electromagnetic radiation at infrared frequencies, right? Which is redshifted compared to red light, invisible. And in Raman spectroscopy, one is looking onto oscillations of atoms, but one is probing sample with optical frequency. So definitely, it's not in a resonance with just low frequency oscillation. It is in resonance with electronic transition. But I'll try to draw something, but it will be more like task for our half-year course. Like if you have vibrational levels for ground electronic state, and then we have vibrational levels for excited electronic state. standard infrared would just make a transition between one vibrational level and pick the frequency. And Raman makes transition from one vibrational sublevel in ground electronic to another vibrational sublevel in excited electronic, making it at the optical, at visible frequency. And then one can go with frequencies which will be more blue shifted compared to fundamental frequency, or red shifted, like one can thermally activate here and then go from thermally activated in ground electronic to lowest non-excited vibrational in electronically excited. And then spectra also look something like this. There are in some countries people hate the name of Raman and they tell it is combinational scattering, because one does different combinations of frequencies in ground, vibration frequencies at ground and excited. So even one diatomic molecule, whereas only one interatomic oscillation degree of freedom may potentially give Raman signal. So, and here is it's not a big discovery or big thought, but I just want to focus your thinking on this aspect. If we neglect quantum thinking, have two masses on a spring as a model of a diatomic molecule, it will have only one frequency of oscillations, right? One and only one. But on Raman experiments, we will see several frequencies. Double, triple, even negative. So how come that we do have oscillating molecule and we can submit there a quantum that twice or thrice exceeds its frequency? What does it mean? So typically experiment goes ahead of theory. Theory is just after trying to explain already known things. So it was first observed, and then one was trying to bring theory was trying to pick it up. So if we, for diatomic molecule, we have like potential, which means it moves forth and back. And if we assume that, according to Sam, it's not a point, but it is like distribution of probability, then instead of moving like a material point, it will generate quantum levels. Right? You saw this picture. Right? So one can and one have to quantize vibrations. Okay. Yeah, it's about 1 minute before our formal end. I think you're already tired of me and ready for a break. So if we take reaction coordinate and consider it is in a quantized way, we can look on a probability distribution that molecules are still in the reactant, but a little bit more or less towards reaction. And then this distribution slowly moving toward the barrier and overcoming or tunneling through it. So one can use how to say, tools, mathematical tools of physical chemistry to predict outcome of chemical reaction. And unlike classical consideration where you need to go over the barrier, there will be probability for reaction to happen even if the thermal excitation is below activation energy. So I think I did answer your question on take-home message from physical chemistry. So enough. If you have more questions, I'm not busy. I can chat more, but probably you are more busy than myself. Okay. Okay. Do you want to stop by and glance over the place for the lab tonight? Let's meet there. Just say hi to each other and then dismiss, just to see the next time we do not spend time on browsing.
At 5.
Yes.
I won't be able to.
Sure, and I will try to record and share recordings.
Quiet without this guy.
I gotta grill up to Gotta find it, more people to join the polls.
Oh, yeah.